So how does a network topology look like for Hadoop? This is a simple 13 node cluster. But in the industry, what will happen is you'll have racks or stands basically, on which multiple of these data nodes are interconnected by a device called as a switch. If you want to interconnect multiple computers to talk to each other, you require a networking device called as switch. Here also there is a switch, but it's called as a Wi-Fi access point. How is that you send a mail from your cell phone and you're able to also see that mail if you have two different email accounts? If you do something if you send an email from account 1 from using your cell phone, it reaches your system. Indirectly you're able to communicate within two systems in your home. Which is that device which enables you to do that? It's a Wi-Fi switch or simply the access point. So here also they have another kind of device called as a switch, but it's hardwired, not Wi-Fi. Everything is hardwired because of the high speed requirement. So you'll have a rack which consists of around 25 to 30 data nodes, one switch, and again all the switches will be interconnected. Networking part, we'll skip it, but for time being just know how it is there in the industry. You'll have a server room with multiple racks, each rack some 25-30 computers, everything interconnected by means of cables, and the device is called as a switch. The advantage of Hadoop is it can be built out of commodity hardware. Commodity does not mean cheap, it means you can go to any vendor and buy it. One of your data node fails, you can go to HP or Dell, or you can go to any company and buy a data node and it'll work. But with massively parallel computing grids and all, right, they have a very strict requirement. You have to go to the same vendor again. If you're having a supercomputer from IBM, if something fails, you have to go back to IBM only to get that node repaired or replaced. That's not the case with Hadoop. Only thing is the software operating system version should be the same in all the machines. So the data nodes typically will be having this configuration. Data nodes will usually have minimum of at least 4 core CPUs, quad core CPU, minimum of 16 GB RAM. Industry deployment, they will not go less than this. They'll go in multiples of that. So typically you can think of 2 hexa-core or octa-core CPUs around 3 GHz speed. It will be the latest in terms of hardware, up to 3 GHz speed. Memory will be anywhere between 50 to 100 GB RAM. Many organizations also operate with 32 GB RAM also, but they'll realize they have to again keep on upgrading. So the better option, have data nodes around 50 to 100 GB RAM. Every data node will have multiples of 2 or 4 terabyte hard drives, not just one hard drive, they'll have multiples of that. So the hardware difference in terms of name node and the hardware difference in terms of data node is that you have your master node, that is your name node, secondary name node. Both of them will have the same configuration. They can probably have anywhere between 4 core to 8 core CPU, anywhere between 50 to 100 GB RAM. Here the hard drive will be less. Hard drive will be less than say 1 terabyte or maximum 2 terabytes. Not a huge hard drive. Hard drive will not be huge. Job tracker also similar configuration. Job tracker also similar configuration. Remember 3 machines in the master mode, name node, secondary name node, job tracker, more or less the similar configuration. Job tracker need not to even have so much of RAM. Now when coming to slaves, that is your data nodes. They need to have lot of CPU power. The more you have, the better. If you can afford even 32 core cross 2, best, go for it. 32 cores and 2 such kind of CPU units in a single motherboard. And the industry norm, like many big companies, have even 200 GB RAM. And each data node will be having close to 50 terabyte storage. 50 terabyte not in a single disk again, multiple hard drives. Like they'll be having like 10 to 15 hard drives. They will never have a single hard drive for failure handling. So data nodes are quite powerful in terms of storage capacity and also in terms of processing capacity. They are much more powerful than most of the masters. Because this is where your computation happens, your processing happens, and this is where your data is stored, not in the masters. Masters just give instructions. And the slaves are the one which do the heavy weightlifting work. So their CPU configuration, RAM configuration, hard drive configuration will be very high. That's called as a local mode. All the service in a single process or a JVM. JVM is actually a Java process or a Java virtual machine. So don't get confused with the terminologies over there. Fully distributed mode is what you'll work in the industry, and what you're practicing now is a pseudo distributed mode. That number can actually vary depending upon the company's requirement. There are companies where data nodes are as small as a quad-core CPU and 16 GB RAM and just 2 terabyte. Small data nodes will be there. But there are companies, depending upon the budget of the organization. If they have a really fat budget, they can actually spend on infrastructure. Hardware configuration, it's better if everybody has the same CPU speed, if everybody is having the same amount of RAM, but it can vary also, nothing is stopping. There is no hard rule here. So it's common sense. If you have better configurations in your data nodes, your job will get executed faster.